Assalamu alaikum, my dear students. Hopefully you are well and safe. Welcome to Mathematics online class. This is Imam Hasan, senior teacher, Department of Mathematics, Milestone College. At last class, we have discussed the basic part of finite series and solved some maths from exercise 13.1. Today we solve the remaining part of exercise 13.1. Let's start our class. My dear students, at last class we discussed the basic part of finite series and solved some maths from exercise 13.1. Today we solve the remaining part of maths from exercise 13.1. At first we solve question number 15. Question number 15, the sum of first n terms of the series 9 plus 7 plus 5 plus dot dot is minus 144. Find the value of n. My dear students, here the given series is an arithmetic series since the common difference are equal. So at first we write the given arithmetic series. The given arithmetic series. Here the given arithmetic series is 9 plus 7 plus 5 plus dot dot, whose first term a equal to here 9 and common difference d equal to here second term is 7 and first term is 9. So 7 minus 9 equal to minus 2. Now here the given condition, the sum of the first n terms of the series is minus 144. So now we have to find the sum of the first n terms. So the sum of the first n terms of the given series equal to, here you all know the formula of sum of arithmetic series, and the formula is n by 2 into 2a plus n minus 1 into d. So n by 2 into 2a plus n minus 1 into d. Here the value of a is 9 and the value of d is minus 2. So n by 2, here 2 into a is 9 plus n minus 1 into d, and d is minus 2 equal to n by 2, 2 into 9 equal to 18, here plus n minus into minus 2, so minus 2n, minus makes plus, 1 into 2 equal to 2. Then by calculation we will get n by 2, here 18 plus 2 equal to 20 minus 2n. Now taking common 2 we will get n by 2 into 2, here 10 minus n. Then by calculation we will get n into 10 minus n. Now here given the sum of the first n terms is minus 144, and by using formula we get the sum of first n term is n into 10 minus n. So according to the question we can write n into 10 minus n equal to minus 144, or here 10n then minus n square, and this becomes plus 144 equal to 0, or minus n square plus 10n plus 144 equal to 0. Now we multiply both sides by minus 1, then we will get n square minus 10n minus 144 equal to 0. Now applying middle term method we will get here, or n square minus 18n plus 8n minus 144 equal to 0, or taking common n we will get n into n minus 18, then taking common 8 we will get n minus 18. equal to 0, or here n minus 18 into n plus 8 equal to 0. Now here the multiplication of two factor is 0. So we can write the first factor, that is n minus 18 equal to 0, or the second factor, that is n plus 8 equal to 0, or here n equal to 18 and here or n equal to minus 8. Here n is the number of term, so the value of n can't be a negative number. So n equal to minus 8 does not acceptable, which does not acceptable. So the required value of n is 18. So our answer, n equal to 18. So the required value of n is 18. Now we solve question number 19. Here question number 19, if the sum of first 12 terms is 144 and 20 terms is 560 of an arithmetic series, find the sum of first 6 terms. My dear students, here the given series is an arithmetic series, but the series is not given. In such a case, we have to let the first term and the common difference. So at first we write let the first term equal to a and common difference equal to d. Now the given first condition, the sum of first 12 terms is 144. So at first we write, so the sum of first 12 terms equal to, here you all know the formula, the sum of an arithmetic series is n by 2 into 2a plus n minus 1 into d. By using this formula, we will get n by 2, that is the number of terms is 12. So 12 by 2 into 2a plus n minus 1 into d. So 12 minus 1 into d. Then by simple calculation, here 12 by 2 equal to 6, here 2a plus 11d. Now the given value of this is 144. So according to the question, we can write here the sum of first 12 terms is 6 into 2a plus 11d equal to, the given value is 144. So 2a plus 11d equal to, dividing both sides by 6, we will get here 24. We denoted this equation as equation number 1. Now our second condition, the sum of the first 20 terms is 560. So now we write the sum of first 20 terms equal to, here you all know the formula, n by 2, that is 20 by 2 into 2a plus 20 minus 1 into d. Now here 20 by 2 equal to 10, here 2a plus 19d. So 2a plus 19d. So the sum of first 20 terms is 10 into 2a plus 19d, and the given value is 560. So according to the question, the sum of first 20 terms 10 into 2a plus 19d equal to 560. Now dividing both sides by 10, we can write 2a plus 19d equal to 56. We denoted this equation as equation number 2. Now at the beginning of the solution, we have letting two variable a and d. So for solving this problem, at first we have to find the value of the two unknown variable a and d, that is the first term and common difference. Now solving equation 1 and equation 2, we find the value of a and d. Now subtracting equation 1 from equation 2, we will get equation 2 minus equation 1. So by this operation, the left hand side of equation 2 is 2a plus 19d minus the left hand side of equation 1 is 2a plus 11d. So minus 2a then minus 11d equal to here 56 minus 24, or here plus 2a and minus 2a are cancelled, and 19d minus 11d equal to 8d equal to 56 minus 24 equal to 32. So the value of d is 4. Now using the value of d equal to 4, we find the value of a. Now we put the value of d equal to 4 at equation number 1. So putting d equal to 4 in equation 1, we will get here at equation 1 2a plus 11d, so 11 into 4 equal to 24, or 2a equal to here 24, this plus becomes minus 11 into 4 equal to 44, or 2a equal to 24 minus 44 equal to minus 20. So the value of a is minus 10. So finally we have the value of two unknown variable, and the values are a equal to minus 10 and d equal to 4. Then by using these two value, finally we find the required answer. Here our question is find the sum of the first 6 terms. So the sum of the first 6 terms, here you all know the formula. The formula is n by 2. N is the number of terms, so 6 by 2 into 2a plus n minus 1, so 6 minus 1 into d. Here 6 by 2, 2 into a, the value of a is minus 10, so a equal to minus 10, plus 6 minus 1 equal to 5 into d. Here d is 4, so 4. Then 6 by 2, here by calculation minus 20 plus 5 into 4 equal to plus 20. So 6 by 2 into 20 minus 20 equal to 0. Then by calculation we will get 0. So the required answer is 0. So this is our required answer. My dear students, now you solve question number 20. Here question number 20, the sum of the first m terms of an arithmetic series is n, and first n terms is m. Then the question is find the sum of the first m plus n terms. Here the series is an arithmetic series, but the series is not given. In such a case, at first we have to let the first term as a and common difference as d. So at first we write let the first term equal to a and common difference equal to d. Now our first given value, the sum of the first m terms of an arithmetic series is n. So the sum of the first m terms equal to, here you all know the formula. The formula is n by 2 into 2a plus n minus 1 into d. Here the number of term is m, so m by 2 into 2a plus m minus 1 into d. Now the given value of this is n. So according to the question, m by 2 into 2a plus m minus 1 into d equal to the given value is n. So 2a plus m minus 1 into d equal to n. Here m by 2 becomes 2n by m. We denoted this equation as equation number 1. Now our second condition, the sum of the first n terms is m. So now we write the sum of the first n terms equal to, you all know the formula, n by 2 into 2a plus n minus 1 into d, and the given value of this is m. So according to the question, this value equal to m. So ATQ, here n by 2, so n by 2 into 2a plus n minus 1 into d equal to m. Then by calculation we can write 2a plus n minus 1 into d equal to, here 2 becomes multiplied, so 2m, and n becomes divided by n. We denoted this equation as equation number 2. Now subtracting equation 2 from equation 1, we will get equation 1 minus equation 2. Then we will get, here the left hand side of equation 1 is 2a plus m minus 1 into d. So m minus 1 into d, then minus the left hand side of equation 2, here 2a, then minus n minus 1 into d equal to, here the right hand side of equation 1 is 2n by m, so 2n by m minus the right hand side of equation 2 is 2m by n. Then by simple calculation, here plus 2a minus 2a are cancelled, then or m minus 1 into d minus n minus 1 into d equal to, at right hand side by taking LCM we get mn, then by calculation we will get 2n square, then minus here 2m square. Now we take common d from the left hand side, so d into here m minus 1, then taking common d we get minus n, then minus minus becomes plus 1 equal to, here mn, and at numerator 2n square minus 2m square. Then by simple calculation, plus 1 and minus 1 are cancelled, so or d into m minus n equal to, here at denominator mn and at numerator 2n square minus 2m square. Since at left hand side one factor is m minus n, so for writing this format we take common minus 2 from numerator. So taking common minus 2, you can write m square, then minus n square. Now solving this equation, at first we find the value of d. Now from this equation we can write, or here d into m minus n equal to, here minus 2 into m square minus n square. By using formula we can write m plus n into m minus n divided by mn. Then dividing both sides by m minus n we can write, so d equal to minus 2 into m plus n divided by mn. So we find the value of d is this. Now our question is, find the sum of the first m plus n terms. So we have to find the sum of the first m plus n terms. So the sum of the first m plus n terms equal to, here you all know the formula is n by 2 into 2a plus n minus 1 into d. So our formula n by 2, where n is the number of terms, here number of terms is m plus n, so we have to write m plus n by 2 into 2a plus, our formula is n minus 1, here the number of terms is m plus n, so m plus n minus 1 into d. Then by calculation we can write here m plus n by 2, then 2a multiplying this md plus nd, then minus d. Now at equation number 1, 2a plus m minus 1 into d equal to 2n by m. By using this value we find the solution. So here m plus n by 2, here 2a plus md plus nd minus d. At the left hand side of equation 1 we have 2a plus m minus 1 into d. We write this one, so 2a plus m minus 1 into d, which is the left hand side of equation number 1. Now here 2a is this one, multiplying this md, here plus md, then multiplying this minus d, here our minus d. So for equating we have to write plus nd, so plus nd, then here m plus n by 2. Now 2a plus m minus 1 into d, which is our left hand side and whose value is 2n by m. So by using this value we can write 2n by m. Then here plus nd, so plus n into d, the value of d is this one, so we can write here minus 2 into m plus n by mn, which is the value of d. Then here we have m plus n by 2, then here 2n by m, here n and n are cancelled, so plus minus becomes minus, here only m, and here 2m, multiplying this we get 2m plus 2n. Then m plus n by 2, here taking LCM as m, we get 2n, then minus 2m, then plus minus becomes minus 2n. Then here plus 2n and minus 2n are cancelled, so m plus n by 2, and here minus 2m by m. Then by calculation we can write minus m plus n, and which is our required answer. So the sum of the first m plus n terms is minus m plus n, which is our required solution. My dear students, finally we solve question number 24. Here question number 24 is a CQ question which stem is nth term of an arithmetic series is L square and kth term is k square. Now question number A, construct two equations according to the given information, considering A as first term of the series and D as common difference. So we have to consider A as first term and D as common difference of the series. So our question number A, at first we have to write let the first term equal to A and common difference equal to D. Now according to our information, nth term of an arithmetic series is L square. So the nth term of the series. Here the series is an arithmetic series, and we all know the formula of nth term of an arithmetic series is a plus n minus 1 into d. Here the number of term is L, so a plus L minus 1 into d. And according to the given information, the nth term is L square. So according to the condition, here the nth term a plus L minus 1 into d equal to L square. We denoted this equation as equation number 1. Now our second condition, kth term is k square. So the kth term of the series equal to a plus k minus 1 into d, and the given value is k square. So ATQ, according to the question, here a plus k minus 1 into d equal to k square. We denoted this equation as equation number 2. Here the equation number 1 and equation number 2 is our required two equations. So those are the required answer. Now we solve question number B. Here question number B, find the L plus k term. From A we have two equations. So at first we write from A, the two equations are this one and this one, where A and D are two unknown variables. So for solving this problem, at first we have to find the value of these two unknown variables A and D. Now solving these two equations, at first we subtract equation 2 from equation 1. So subtracting equation 2 from equation 1, we will get, here the left hand side of equation 1 is a plus L minus 1 into d, then minus the left hand side of equation 2, that is minus a minus k minus 1 into d, equal to here L square minus k square. Now plus a and minus a are cancelled, so here L minus 1 into d, then minus k minus 1 into d equal to L square minus k square. Or here taking common d, we will get L minus 1, then here minus k, then minus minus, so plus 1 equal to L square minus k square. Now d into here plus 1 and minus 1 are cancelled, so L minus k. At right hand side, by using algebraic formula, L square minus k square equal to L plus k into L minus k. Now dividing both sides by L minus k, then we will get d equal to L plus k. So by solving the two equations, we find the value of d equal to L plus k. Now by using these two equations and this value, that is d equal to L plus k, we find the required answer. Here the question is find the L plus k term. So we have to find the L plus k term. So the L plus k term of the series equal to, here you all know the formula, the nth term of an arithmetic series is a plus n minus 1 into d. Here the number of term is L plus k, so a plus L plus k minus 1 into d. So here a plus multiplying this L d plus kd minus d equal to, now by using the equation number 1, we solve this problem easily. Here the left hand side of equation 1 is a plus L minus 1 into d. So we write this one a plus L minus 1 into d, which is the left hand side of equation number 1. Now here this is our a, then multiplying this plus LD and then minus d. So for equating these two lines, we have to add kd. So plus kd. Now the value of a plus L minus 1 into d is L square from equation 1. So equal to L square plus kd. Here k into d, the value of d is L plus k, so L plus k. Here we use the equation 1, so we have to write from equation 1. So from 1. Then here L square, then multiplying this plus KL, then plus k square, which is our required answer. So the L plus kth term is L square plus KL plus k square. Now question number C. Prove that summation of first L plus k terms of the series is this. So we have to prove this one. Here from A we have two equations, A plus L minus 1 into d equal to L square and A plus k minus 1 into d equal to k square. And from B we have the value of d, which is L plus k. Now we find the summation of first L plus k terms. So the sum of first L plus k terms of the given arithmetic series equal to, here you all know the formula. The formula is n by 2 into 2a plus n minus 1 into d. Here the number of terms is L plus k. So we have to write L plus k by 2 into 2a plus L plus k minus 1 into d. Now here L plus k by 2, multiplying this we get here 2a, and then multiplying this we get LD plus KD minus D. Now here L plus k by 2. Now here 2a. If we add equation 1 and equation 2, then we get at first 2a. So for removing the unknown variable a, we have to add equation number 1 and equation number 2. So the left hand side of equation 1 is a plus L minus 1 into d, plus the left hand side of equation number 2 is a plus k minus 1 into d. Now we have to balance these two lines. Here a plus a equal to 2a, multiplying this one is LD, here this one, and this one is minus d, so this is minus d, and then here KD, this is KD, and then here minus d. So for equating these two lines we have to add plus d. Now L plus k by 2, here a plus L minus 1 into d, which is our left hand side of equation number 1, and whose value is L square. So L square plus a plus k minus 1 into d, which is the left hand side of equation number 2, and whose value is k square. So we have to write k square plus d. The value of d is L plus k. So L plus k, and this is our required answer. We have to prove summation of first L plus k terms of the series is L plus k by 2 into L square plus k square plus L plus k, and here this is the required value, L plus k by 2 into L square plus k square plus L plus k. So proved. My dear students, hopefully you will understand today's class. If any problem, take help from your subject teacher. Thank you. Allah Hafiz.